All right, so today's session, we're just going to be talking about reusable components, helper functions, custom hooks, and project organization, all with the goal of writing cleaner and more professional React code. So this is going to be the agenda for today. We'll just start by talking about why reusability matters in React and how do we go about implementing that. And then we'll talk more about how children props give us more flexibility. After that, we will just be looking at helper functions, custom hooks, when to use one versus the other, and then and then we'll finish this presentation with project organization and the main takeaways before we jump into the code example. Before I move ahead with the presentation, if you guys just put your names in the chat, so that way I will know who is there, who is currently attending this session. Okay. Why you guys enter this name? The names. So let's just start with why do reusable components matter? So they matter because they help us write something once and use it in multiple places instead of duplicating the same code over and over. That in turn gives us two benefits. Uh, First benefit is consistency and speed. If you find that there are certain buttons, cards, or badges, all come from the same reusable component, the app stays more consistent and updates become much easier. A good sign that something should become a reusable component is when you start to notice repeated JSX pattern. So if you're copy pasting code, this is a strong signal that a reusable component is just waiting to be born. And the way that we usually get there is in stages. First, we make the component flexible with props so that it can handle different data or styling variations. Second, we make it versatile enough to work in multiple contexts and not just for one specific screen. And third, we can make it even more adaptable with defaults and the children prop, which give us more control over what gets rendered inside the component. And let's try to go over. A practical way to build a reusable component. The first step would be to start specific. It is completely fine to begin with hard coded values first, just so we could get an idea of the structure and the style and the styling right as well. And then once the component works, they try to take a look at what needs to change. Usually that would involve certain things like text, colors, or actions. Those become our props. And then for variations, we could use one clear prop like kind, or instead of creating a bunch of separate boolean props like is primary or is secondary. On the right hand side we can see one small example where the first button is kind of like hard coded, but under that we can you can always see how we could refactor that into a reusable card component that accepts the kind of card that this is. Oh, okay. So this is an example of a car of the card component which can be which can be used as a button. that accepts a kind prop and uses children for the label. And that brings us to, to the children prop. Oh, okay. Okay, so this was the example. Yeah, so this was the reusable button component that I was talking about. And then, so in this case, instead of hard coding but the button label, what we can do is we could we could place it inside the children prop. It is a special prop that represents whatever we place in between a component's opening and closing tags. So in this case, instead of hard coding the button label, we can pass in something like submit or save or cancel as the children. So that makes the component much more flexible, while the parent controls the content inside. And now let's try to talk more about uh, and the idea is powerful because it enables composition. In other words, the parent component can define part of the child component's components, which is why children is so useful for building reusable wrapper components. And let's try to and and the children props is kind of powerful because it enables a composition. In other words, the parent component can define parts of the child component's content, which is why the children prop is so useful for building reusable wrapper components. And then a simple metaphor to understand is that I will handle the content and styling, and then the you decide what goes inside. So on the right, you can see that the card component returns a wrapper with the card class and renders the children inside it. Then, in the usage example, we can see place a title, a paragraph, or really any JSX code inside that card. And now let's try to talk more about helper functions. So helper functions are nothing but pure functions or functions which are purely written in JavaScript. They don't use React. They use none of the React state effects or hooks. Their job is to handle logic that doesn't belong inside the component itself. They're especially useful for things like calculations, data transformations, and formatting. The main benefit of using helper functions is cleaner code. Your component stays focused on describing the UI, while the helper function handles the logic behind the scenes. They're also easier to test because a pure function can be tested by itself without rendering any components. And then in the example on the right, we have just one simple format date helper inside the formatters .js file. It just takes a date string and it returns a nicely formatted date using the toLocale date string method. And then inside the component, we just simply import that helper. And we, instead of using the local the date string method, we could just import use the helper itself right in the JXX. So instead of putting formatting logic directly inside the component, we move it to a utility file and keep the component much cleaner. So, uh, if logic doesn't touch React state or hooks, it belongs in a utilities file, not inside the component. And now that brings us to custom hooks, which are for reusable stateful logic. A custom hook is useful when the logic does depend on React features like state, effects, or other hooks, and you want to reuse that logic across multiple components. So there are three ideas here when it comes to using custom hooks. The first, the custom hooks must start with the prefix like use local storage or use form dirty, and then the second principle is composition. A custom hook can call other React hooks internally, like use state and use effect, and the third principle behind custom hooks is that the analogy is just as components you reuse the user interface. Custom hooks reuse logics with stateful memory, and then on the right, we can see an example where the use local storage is a custom hook that wraps state plus the local storage behavior into one reusable function. It reads an initial value from local storage, keeps it in the React state, and returns the stored value along with a setter. So the simple rule for creating custom hooks would be if the logic is plain JavaScript, use a helper function. But if the logic uses React state or FX, it is that's a good case for a custom hook. And this slide gives a really clear side-by-side examples. Helper functions do not use React hooks. They do not manage state or effects, but custom hooks do. Helper functions can have any normal function name like format date, but custom hooks must start with use. So that is not something that is mandatory, but it is a good naming convention that has been used by React developers almost everywhere. Okay, I see that someone has raised their hand. Do you have any questions?
I have one for separating the code into utils. What would you say is how can you benefit from doing that? Like, what is the advantage of doing that?
So the that's actually a good question. So the main advantage of separating code into utils is that it keeps your components focused on rendering the UI instead of mixing the user interface with extra logic like formatting, calculations, or data transformation. It also makes that logic reusable. So let's say if multiple components need the same date formatter, or it could be a message generator or calculation, you could just write it once in util and import it wherever you need it. Another benefit would be testing. A helper function in utils is usually much easier to test on its own rather than testing that component which is buried inside the logic, and it also helps us improve maintainability. So if you ever need the to update that logic, you can do it in one place instead of trying to make that update through multiple components. I hope that
Hmm.
answered your question.
So, in other words, it's helping you keep things organized and helps you. It gives you like a tool that you can use over and over again.
Yes, that is exactly it.
Okay, interesting.
All right. So, and that's the key difference we're looking at here. Helper functions help us reuse pure logic, while custom hooks help us reuse the stateful React logic. So if it doesn't use React hooks, doesn't manage state, and is mainly just doing formatting or calculations of any kind, that usually belongs in a helper function. But if it does use React state, effects, or any other hooks, that is a better case for a custom hook. And this is pro And now let's try to talk about project organization, which is really more about making your code base easier to navigate as the app grows. One of the best practices is using a feature-based structure. That means instead of grouping files by feature like products or profile, it's instead of only grouping by file type. This makes the related code easier to find because pages, and logic for one feature stay close together. Another best practice is having shared folders for things that can be reused across the app. Those could involve shared components, shared hooks, or shared utility functions. You also want clear top level directories inside the source directory, especially for places like hooks and utils. So, reusable object has one obvious stop, and then finally, a layout component is useful for persistent UI. So that could involve things like a header, a footer, or a page that is shared by multiple screens. And here is what a typical structure of a React app would look like. You can see that there are features, and then there are shared components and layout components as well, along with some hooks and the utils which contain our helper functions. The main idea is not that there's only one perfect folder structure, but the your structure should be clear, scalable, and predictable. So let's try to so let's try to discuss what has been discussed so far. So and let's try to understand some key takeaways from today. The first one, modular components should stay small, flexible, and focused on a single responsibility. Second, utility helpers are a great place for pure logic, and we can keep our components clean and they're easier to maintain. And then third, custom hooks help us share stateful logic across the application in a reusable way. And then lastly, organized structure matters. A clean folder structure is really an investment in the future of your project because it makes the code base easier to scale and easier to work in. And then for next week, the big habit, one of the other habits that developers usually build on is refactoring. But writing code is one step, but improving over time is what helps you grow as a developer. And for our next session, we will try to build on this by looking at data fetching and asynchronous behavior in React. And I'll just stop here for a moment to see if you guys have any questions about the presentation so far. Okay, what about the rest? Do you have any questions so far about the uh, about about the presentation that we just discussed before we move on to the coding examples that I have set up for the session?
Think I could get a copy of the presentation.
Yes. So after this session, I will be posting the recording, and I will also be putting up the presentation along with the coding examples that you will be seeing right in the next 5 to 10 minutes.
Okay. Because I got here a little late because my computer was being a little being extra. It wouldn't let me join in.
Yeah, that's totally fine. That's nothing to worry about. That's the main reason why these sessions are recorded, so that you can always look back to what you have missed, just because you've been slightly later than usual. So, if there are no more questions, let's move on to the coding example that I have set up for this session. I Let me know if you guys can see my screen. Okay. So for those of you who were here last week, if you could take a quick look at the file structure on the right, this is what we had set up for as our example, where we had multiple components like the counter, the shopping list, and the student card itself, where we had taken a look at the confirm cancel at the concepts from previous week. Now, if I try to, now what I've done is I will be switching out to another branch. This is kind of like a version from last week, and we already had multiple components. And now what we're going to do is we're going to move to another newer version, because the goal this week is not just to make the app work, but to make the code cleaner, more usable, and better organized. So that is exactly why I wanted to show you the earlier structure for context, and then I'll just switch over to the refactor branch so that we can clearly see what has changed and why. All right. So now we are in the refactored version, and even from the file structure itself, you can already start to see better organization. Instead of keeping everything in one general components area, the code is now organized more intentionally. We have a feature related folders, some shared components, a hooks folder, and a utils folder. So, for example, inside the shared folder, we have things like the dialog and the status batch, which tells us that these are meant to be reusable across different parts of the app, not just one tied to one feature. We also have the use form dirty inside hooks, which is a good example of reusable state logic, and then the counter utils inside utils, which is where pure helper logic belongs. As we open this file, I want you to this. I hope this will help you notice every change maps back to one of the ideas from the presentation, whether it involves reusable components, helper functions, custom hooks, and better and project organization. So let's take a look with the features itself, and that is the counter. Let me just try. Okay. Okay, so this is the let's start with the counter, because this file shows all the ideas from the presentation in one place. We There are the imports at the top. Notice that we are importing the use form dirty from the hooks folder, and the get counter message from the utils folder. It is a separate function. That alone helps us understand that we have separated reusable stateful logic from reusable pure logic. And then inside the component, we still have a local state for count and input value because that state belongs specifically to the counter. But instead of manually managing the form dirty behavior inside this file, which is a way to check if there have been changes that are yet to be saved, we would just call the custom hook that is called use form dirty. That is the custom hook refactor. We extracted repeated stateful behavior into a reusable hook, and now the component just consumes it. And now for the message logic, instead of building that message inside the effect, we just call get counter message. And this effect is still here because logging is a side effect, but the message making logic itself was moved into a pure utility function. So this is one example of how you can separate different concerns. The component focuses on rendering and wiring things together. The hook handles reusable state logic, and the utility handles pure JavaScript logic. And uh, let's take a look at a look at the use form dirty hook right here. It just let's open the custom hook itself so you can see exactly what was extracted. So this hook encapsulates the is form dirty pattern. So instead of rewriting the same checking logic in multiple components, we can define it here once and reuse it whenever we need it. So at the top, I have of course used the use state hook, which is the reason this belongs in the hook folders and not in the utils folder. And there we have the mark dirty function, which sets the form to dirty, and it calls this is effectively called when the user makes a change, and mark clean helps reset the it back to false whenever the user confirms or cancel. And then at the bottom, the hook returns is form dirty, or it returns an object so which contains the following for the variable called as home dirty and the functions itself, so that any component can import this hook and immediately get that same behavior. So compared to last week, the main improvement is that this logic is no longer duplicated inside individual components. We have managed to extract this into a custom hook, which give us cleaner components and reusable state logic. And now let's try to take a look at our function itself. And hopefully this should give you a better idea.
That export function caught my attention.
I'm sorry.
That export function caught my attention. It's the first I've seen it, but how come it's called export function but not export default?
Oh,
And
okay.
how are you passing
Eh,
it through to a custom hook?
Right. So that comes down to the difference between a named export and a default export. So when I write export function use form dirty, I'm creating a named export. That means when I import it, I need to use the exact same name inside the curly braces, like import this particular function. But if I used export default, then I would import it without the curly braces, and then there is a chance that and then I could technically rename it to something else when importing. So both approaches work. The reason I used name export here is because utility functions and hooks are often exported that way for clarity, especially when a file might eventually contain more than one export. So, in short, named export means exact name with braces, and then the default export means no braces, and the import name can be more flexible. I hope that answers your question.
It kind of does. It kind of does. It kind of sounds like you're saying that export default kind of imports the whole thing, but export function it makes it kind of specific in a way.
Yes.
So it's exactly that. Export function makes it more specific on which one to call, while export default calls the whole thing.
No, y- close, you're close, but not exactly. So the main difference is not that export default exports the whole thing and named exports only part of it. Both are exporting something from the file. The real difference here is how you identify and import it. So with the named export, you are explicitly saying export this thing by its exact name. So when you import it, you must reference that exact exported name with the curly braces. Now, and then with the default export, what you're practically saying is that this is the main export of the file. Then when you import it, you do not use curly braces, and you can also choose the import name yourself.
Hmm. So function you use a curly braces, while default you don't have to use a curly braces, and that's for importing it.
Yes, and also if one would think to understand, if you're exporting it as a default component, you don't have to explicitly use the name right as I've used it. You can use it to you can use to name it something else, or and then if you're trying to use a default export, then there is no need for curly braces as well.
Okay, got it. Interesting. It just stuck out to me, so I had to ask something about it.
Oh no, no. I actually like it when I'm asked questions like this. It also helps me understand what are some other parts that could use more emphasis on. So I really appreciate the questions. If you do have any other questions, feel free to put it in the chat or unmute yourself just like you did. And this is the counter example that we have just seen. Let's take a closer look at it. You can see, hold on. Let me see if I can try to use it in my, okay. So on the page, you can see the note that, okay. So let's take a look at our counter here. And then the count is still belongs here in the counter because that part is kind of feature specific, and the input for setting the count directly is where the dirty state behavior becomes useful, because as you soon as the user types, we can track that there are unsaved changes, and when we confirm or cancel, that shared hook handles resetting the dirty state instead of us rewriting the same logic in every component. And right below it, you can see the shopping list example, which we'll see in a few moments, that it shows the exact same custom hook that is being reused in the same culture. And yeah, so this is the counter example that I had. Uh, okay, let's take a look at our shopping list. So this, so Here in the shopping list feature, you can see that the exact same hook is being used again. This is exactly the benefit of extracting shared stateful logic. You can see that we have imported our built-in hooks like use state and use ref, and we have also imported our custom hook as well. And then and here, right here is where we can see that this custom hook is being used entirely, and that kind of reinforces the point of using custom hooks. You can just write once and use it everywhere. And this is the but the dirty tracking the component still has its own feature specific skills like the array of items, and then the working items, and then the input ref, because that logic belongs specifically to the shopping list. But the dirty tracking is no longer rewritten here. So when a user adds an item, we can just mark it dirty, which lets the user know that there are changes to either save, confirm, or cancel. And then later, when the user confirms or cancel, we can just use the mark clean function. So compared to last week, we have kept these shopping specific behavior inside this component, but we have extracted the reusable dirty state behavior inside into the hook. And then you can see that the feature logic stays here, and then shared state behavior lives inside this hook. And then if we try to add other items, the core functionality still remains the same. If I cancel, it gets removed. If I confirm this, it stays in the list. And let's try to and then this is just the JSX code that you can see right here on the screen. It's basically your standard HTML along with some CSS. And so let's try to take a look at the student roster section. So now we're looking at another kind of reused. Not it wouldn't be shared logic this time, but and rather we would be looking at shared UI. This student roster is also showing us the status badge component. The key idea here is that the selected badge and the featured badge are both instances uh, of the same reusable component, just with different props. So, for example, our student markers here has a featured badge, and in another case, the same badge component could render a selected state or a different label just by changing the props that we pass in. So this is what we had talked about in the previous presentation. So instead of hard coding separate batch elements for every variation, we create one reusable component and let props control the differences. So there's also you also have to note more about stock propagation, which is also very useful because it prevents a click on the badge or the inner element from accidentally triggering the parent's card click handle. So I think that's a nice example of keeping component behavior intentional and predictable. So compared to last week, this is kind of like a UI refactor. And let's try to take a look at the code. Uh, So this is just the student card component. Uh, this just handles feature specific things like the name, grade, uh, and highlight, and the on select, and uh, is select. So the student card still owns the behavior that is specific to this feature. And down here, the batch UI is no longer hard coded as separated pieces of JSX. Instead, we render the same status batch component in two different ways. So if is selected is true, we render the status batch with the label selected and its color. And then if the highlight is true, we render the status patch with the label featured and a different color. And this is the so this is an example of how we can reuse different components like these through props, and same component, different label and color, and we could see a different result on the screen. And this yeah so this is the reusable component itself. You can see how small and focused it is. The status badge only cares about one job, which is displaying a badge with a label and a color. So it accepts label and color as props, which also makes it flexible. And then different parts of the app can reuse the same component and just pass different values. You can also see that we have a default color value here, which is green. So even if we forget to pass a color, the component still works, which makes it a little more resilient. And then this is an example of how modular components would come out, and they're small, single purpose, and they're easy to reuse anywhere in the app that needs a small status indicator. Now let's take a look at our at this dialog component, and this is probably one example of combining multiple reuse ideas for ideas in one component. At the top, you can see that we have created two objects, one for colors and one for icons. This is a design choice because instead of writing a long chain of if statements, we can map each kind to the values that we want. And then, and then if we ever want to add a new dialog type later, like maybe let's say it could be another warning or like a soft warning, we mostly just update those lookup objects instead of rewriting the whole the component logic. And then this component takes in the children props and the kind, and then a property called on dismiss. The kind prop controls the variation, and it decides what color to use. And then the children prop controls the content inside, which is exactly what we had discussed in the presentation earlier. The dialog handles the wrapper and styling, while the parent decides what message or what kind of JSX goes inside. And you can also see that our kind property here defaults to info, which means that the component still works even if we do not pass a dialog type. So this is a reusable shared component that uses props, defaults, and the children altogether to stay flexible without becoming complicated. And now let's see how it exactly works. So you can see that on reloading the page itself, you can see the info. Right now it's just rendering an info dialog, and the reason that it can do so is because the kind prop is controlling the visual variation while the message inside is being passed as the children prop. And these buttons right here are a great demo for reusability. We are not creating four separate dialog components for info, success, warning, and error. We're just using the same dialog component, and just we're changing the kind prop. So if I click success, you will see the same wrapper component, but the only difference is the color and the icon. So, and while the entire structure stays the same. So this is exactly what I had meant by reusable components. There's just one component with multiple variations, and these are controlled by props instead of duplicated GSX. And I think this is the coding example I had in mind. This is about all the features that I had covered for I had prepared for this session. And now I would just like to take a moment to go over the yeah, and that covers all the main refactor examples that I wanted to show you today. And then I'll just pause here and see if anyone has any questions about the code that we've just seen, or about where do we use each one of these patterns.
Yes, I will send to you is about assignment 4, and it shouldn't be that much this time. That the second time I'm reviewing. Uh,
Um,
okay,
okay.
all right.
Let Yes, well, I think we can talk later, right after the session ends.
Okay, no
Try to-
problem. No problem. Thank
we'll
you.
just we'll just try to see if anyone has any questions about the coding examples that we've just seen, or the presentation from before.
Excuse me. Why you say was the dirty
Oh,
function? What is it?
oh yeah, I think you mean this. So,
Yeah.
okay, so here dirty does not mean bad code. It just is a way to indicate that the form has been changed, but those changes have not been confirmed or reset yet. So that is why I had created this scope called form dirty. It starts as false, and then once the user types or makes a change, we call this function, and which would help us inform the user that there are certain changes that needs to be either cancelled, or they need to be confirmed.
Cancel or it has been changed, you say, right?
Yes,
Or confirm. Okay. Cancel or what else you say the last word?
confirm.
Confirm. Oh,
Right.
all right. Confirm. Okay. Okay. Uh Thank you.
Okay. Are there any more questions?
Is there a recording that we can rewatch?
Yes, this session is being recorded, and then we once this session is over, I'll be posting this recording in the announcements channel itself.
Okay. Thank you.
Uh, uh, okay. Well, if there are no more questions, I would just like to go ahead and wrap up for today. And I would just like to say thank you all